Welcome back, Honors 8th grade math. We are going to do chapter 6, section 4 today, and we're going to start section 5. So basically, there's three different situations when you graph two equations. You either have parallel lines, which means that there are no solutions. You would graph one line, and then when you graph the other line, it would be the exact same equation, and that would be all solutions. And the last situation is where you would graph one line, and then you would graph the other, and they would intersect somewhere, and there would be one solution, the point where they intersect. So I'm going to give you a couple different equations, and you're going to solve for the point that they cross and tell me which situation it is. So the first problem is 2y equals 6x plus 4 and 3x minus y plus 2 equals 0. So to solve this, you would need to possibly put them in y equals mx plus b. So for the top one, you would divide everything by 2 to get the y alone. So y equals 3x plus 2. And in the second one, to get the y alone, the first thing you would do is get the 3x as well as the 2 over to the other side. So now you have negative y equals negative 3x minus 2, but we're always solving for positive y, so you could think of that as dividing by negative 1. Y equals 3x plus 2. So maybe you already noticed that they're the exact same. If you didn't notice, you'd basically make a table and the tables would be the exact same. The easiest number to plug in when making a table is 0. When you plug 0 in, you get 2 because 3 times 0 is 0 plus 2 is 2. Now the slope is 3, so every time you go up by 1, you're going up by 3. So if you plug 1 in, you would get 5. You can test 3 times 1 is 3 plus 2 is 5. When you plug 2 in, you could just add 3, or you could plug it in and solve. And then basically when you graph those, you get the same exact line. Second problem is y equals x minus 4 and 3 plus x minus y equals 0. So again, the easiest form probably for you is y equals mx plus b. And if we're going to do that, you would need to move the 3 and the x over to the other side to isolate the y. And do not lose the negative. I'm going to put the x first for mx plus b. I'm keeping this negative with the x, this negative with the 3, and this negative with the y. If the slashing and dashing helps, that's a great tactic. And then you need to get rid of the negative in front of the y. You can think of that as dividing everything by negative 1 or by multiplying everything by negative 1. So this equation is y equals x plus 3. This equation is y equals x minus 4. Both of them have the same exact slope of 1. So since they have a different y-intercept, they should be parallel lines that never cross each other. But we can confirm that. If you plug 0 into this equation, you get negative 4. 1 would give you negative 3. 2 would give you negative 2. If you make a table for this equation over here, 0 would give you 3. 1 would give you 4. 2 would give you 5. So in both situations, the slope is 1. They are going up by 1. If you sketch a graph of that, this one is this. And then this one here is over 0 up 3, over 1 up 4, over 2 up 5. It should be the same exact slope because they have the same slope of 1. Different y-intercept. This one has a y-intercept at negative 4. This one has a y-intercept at 3. Different y-intercept, same slope, same rise over run. All right, third problem. Y equals 3x plus 2 and 2x plus y equals 7. So in order to figure out what situation, again, most likely you would put them both into y equals mx plus b. Therefore, you would subtract the 2x. So the second equation is now y equals negative 2x plus 7. You really don't need to look at this form of the equation again. So you have two equations. They have a different slope and they have a different y-intercept. So they are going to cross, just a different slope they're going to cross. So the easiest way to solve this is probably substitution. Right here, this y and this y are the same. So you can literally set the two things equal to each other because the y's are the same. So 3x plus 2 is equal to negative 2x plus 7. So I'm technically plugging that in there because these y's are the same. So now you will solve for x, add 2x because you want all of your letters on one side. So 5x plus 2 equals 7. And then you want all of your numbers on the opposite side. So subtract 2. 5x equals 5. Divide by 5. So you have x equals 1. Once you find the x, you do need to find the y. So you're going to go back to the original two equations. It might be a great idea to plug them into both and make sure you did this right. If you plug 1 in for x, you get 3 times 1 plus 2, which is 5, and if you plug 1 in for this x, you get negative 2 times 1 plus 7, which is 5. So regardless, the ordered pair point is 1, 5. So that is the solution. That is the one point that they cross. All right, we're going to move into Chapter 6, Section 5, since that was kind of a short little lesson. Now, this is going to add inequalities into everything. So let's before we do too much inequality graphing, do you remember beforehand when you just looked at a number line and you went to negative 5 and you would have an open circle because there's not an equals to sign right there, and then because this is greater than, you would graph it to the right? Well, that's lovely, but now we could actually graph the equation just like you graph a typical equation on a coordinate grid, not just a number line, but an axis. So if you have something like y is less than or equal to 3, I actually want you to think of this as a y equals equation. Do you remember if this is horizontal or vertical? If you have no recollection, you could make a table. Anything goes in for x, and y is always 3. So that would be over 0 up 3, over 1 up 3, over 2 up 3, over 3 up 3. Now because of this equals to sign right there, this is a solid line. And then because this reads less than, we are going to shade to the less than numbers. You're shading down. So let me give you another one to graph. Y is less than x plus 5. So you're thinking of this just like an equation, a basic equation, that's a y equals x plus 5. So if this was the case, we would start at 5, that would be your b, and your slope is 1. You could put a 1 right there if that helps you out. And so every time you go up by 1 in the x, you are going up by 1 in the y. So in order to graph that, you would start at 5, and every time you go up 1 in the x, you're going up 1 in the y, and so forth. Now, typically you would draw a line through those dots because of the equal sign. Well, in this case, there's not an equals to sign underneath. The one above, we had the equals to sign right there. This one we don't. So it's a dotted line, because the dots on the line are not solutions. They are not equals to. And then this reads less than, so again, you're going to shade going down towards these smaller numbers. If it read greater than, you would have shaded above since it's going up. So basically, if you have a line like this, this is the less than side that you would shade, and this is the greater than side. If you have a line that goes down, this is the less than, and this is the greater than. If it doesn't say equals to, this is dotted. It's not solid. So you have an option of either having a dotted or a solid. And then if your line is vertical, this is greater, and this is less. And if your line is horizontal, the less is below, and the greater is above. Okay, so let me give you one to try. Y is greater than or equal to 2x minus 3. So your first step is you're just kind of thinking of this without an inequality. If it wasn't in y equals mx plus b, you would want to put it in y equals mx plus b. Since you have an inequality, don't forget if you ever multiply or divide by a negative, you do flip the inequality. So basically, if you plug 0 in, you would get negative 3 if it wasn't equals. And then you're going up by 2. So 1 would give you negative 1, 2 would give you 1, and 3 would give you 3. So when you plot that, you have 0 giving negative 3, 1 giving negative 1, 2 giving 1, and 3 giving 3. Now, is this line dotted or solid? We're going back to the inequality, and there's an equal to sign right there. So it is a solid line, straight, and then it reads y is greater than. So anything above will work. So if the question said, is 0, 0 a solution? Well, you could plug it in, 0 and 0, and say, well, yes, that works. You could also just look at the graph, 0, 0 is right here, so yes, it works. So you can figure out any solution at all. Okay, story problem. You have 285 beads and you are a jewelry maker. The necklace takes 40 beads to make, and a bracelet takes 15 beads to make. Go ahead and write an equation and graph the inequality and then list a couple solutions. So the equation would be 40 beads per necklace plus 15 beads per bracelet equals 285 beads. It doesn't matter which is y and which is x in this situation. I'm just going to think of this as y and this as x because when you're solving for y, it's easier if you have the smaller number, but again, it doesn't matter. So if you would like to graph this, you could graph this with the x and y intercept. That's one option. So for the x-intercept, since it's in standard form, you would plug 0 in for y and solve for x. So if you plug 0 in for y, you would have 40n equals 285, and then 285 divided by 40 would be, let me grab my calculator off this, 285 over 40. 285 divided by 40. 7.125. So that's the x-intercept. The y-intercept, you would plug 0 in for x and solve for y. So you would have 15b equaling 285, and then dividing by 15, if you go back to the calculator, 285 over 15. You get 19. So that's one way to plot it. Another way to plot it is to solve for y. So you could subtract 40n, so 15b equals negative 40n plus 285. And then if you divide everything by 15, you would get b equals negative 8/3, because you could take a 3 out of both of those, plus 285 over 15 is 19. So this is another option to graph it where you could make a table and 0 gives you 19. And then this is your rise over your run. So every time you go up 3 in the x, you're going down 8 in the y. So 3 would give you 11, and 6 would give you 3. And that's why 7.15 gives you 0, because then we're going to be in the negatives, which doesn't make a lot of sense because the domain, you need to have the beads. Okay, so let's go ahead and plot this. 0 gives you 19. I'm just going to count by fives. It's going to be an approximation. And 3 gives you 11. And 6 gives you 3. And 7.125 gives you 0. So is this going to be a... Oh, okay. You want to make, if you have at most 285 beads, your inequality would be at most, that means you could have 285 beads or less. So going back to solving all of this, the inequality would be less than or equals to. So you would have a solid line going through each of those dots, and then the less than or equal to you would shade. There's really no need to go past either axis because the negatives don't make a lot of sense if you think about the situation and the domain and the range. So any and every point in here are the points that make this work. So we could say that you could make 1 and 5, and our X is our necklaces and our Y is our bracelets. So any ordered pair combination that is in this range right here works. So this is all of the good data. So you can list any ordered pair in there, making it way less. Well, tomorrow we will look into graphing 2 inequality lines, and where their shadings cross is your solutions. So hold your breath and get excited for that. Actually, breathe very deep. Have a lovely evening.